Good afternoon, everyone. Today, I would like to talk about the 2024 Nobel Prize in Physics. I chose this topic because it shows how ideas from physics helped create powerful tools for machine learning. The prize was awarded for foundational discoveries and inventions that enable machine learning with artificial neural networks. At first, this topic may sound more like computer science than physics. However, the key ideas are deeply connected to physical systems and the way complex patterns can be stored and processed. One important part of the prize concerned the work of John Hopfield. He developed a network, now called the Hopfield network, that can store and recover patterns. For example, even if some information is incomplete or noisy, the network can still recognize the original pattern. This is possible because the system moves toward a stable state, much like a physical system seeking a lower energy configuration. In this way, the Hopfield network showed that ideas from physics could be used for pattern recognition and memory. The second major part of the prize concerned Geoffrey Hinton. He helped develop methods that allowed artificial neural networks to learn from data more effectively. His work made it possible for networks to identify patterns, classify information, and improve their performance through training. This became one of the foundations of modern machine learning. Artificial neural networks are inspired by the structure of the brain. They consist of connected units that process information together. By adjusting the strength of these connections, the system can learn to recognize images, understand language, and make predictions. This discovery was extremely important. It showed that machine learning with artificial neural networks could be built on fundamental scientific principles. It also created the foundation for many of the AI systems that are now used in science, medicine, and everyday technology. I find this discovery very fascinating. It shows that ideas developed in physics can influence completely new fields. It also teaches us that understanding complex systems can lead to tools that change the world. In the future, artificial neural networks may become even more powerful and useful. Even though this topic may seem modern, it gives us an important message. Basic scientific ideas can lead to revolutionary new technologies. Thank you.
Good afternoon, everyone. Today, I would like to talk about the 2024 Nobel Prize in Chemistry. I chose this topic because it shows how scientists can now both predict protein structures and design entirely new proteins. The prize was awarded for computational protein design and protein structure prediction. At first, this topic may sound very technical, but the basic idea is clear. Proteins are essential molecules in living organisms. They act as enzymes, signals, transporters, and structural components. Their function depends strongly on their three-dimensional shape. For many years, one of the great challenges in chemistry and biology was to understand how a protein sequence determines its structure. One part of the prize concerned protein structure prediction. Demis Hassabis and John Jumper developed methods that made it possible to predict the three-dimensional structure of proteins from their amino acid sequences with remarkable accuracy. This solved a problem that scientists had struggled with for more than 50 years. As a result, researchers can now understand protein structures much faster than before. This has greatly helped biology, medicine, and drug discovery. The other part of the prize concerned computational protein design. David Baker developed computational methods for creating entirely new proteins that did not previously exist in nature. In other words, scientists are no longer limited to studying natural proteins. They can now design proteins with new shapes and new functions. This is a major breakthrough. It means that proteins can be engineered as practical tools. For example, designed proteins may be used in medicine, vaccines, catalysis, and environmental technology. Together, these discoveries were extremely important. Protein structure prediction helps us understand life's molecular tools, while computational protein design allows us to create new ones. I find this Nobel Prize very fascinating. It shows that science is moving from observation to creation. It also teaches us that once we understand structure deeply enough, we can begin to design function. In the future, these methods may lead to new medicines, better enzymes, and innovative materials. Even though this topic may seem advanced, it gives us an important message. Understanding nature can eventually give us the power to build new forms of it. Thank you.
Good afternoon, everyone. Today I would like to talk about the 2024 Nobel Prize in Physiology or Medicine. I chose this topic because it reveals a fundamental mechanism that controls how genes function inside our cells. The prize was awarded for the discovery of microRNA and its role in gene regulation. Genes contain the instructions needed to build proteins, which perform most functions in the body. For a long time, scientists believed that gene expression was mainly controlled at the level of DNA transcription. However, the discovery of microRNA showed that regulation also occurs after transcription. MicroRNA is a type of small RNA molecule that does not code for proteins. Instead, it binds to messenger RNA and prevents it from producing proteins. In this way, microRNA acts as a fine-tuning system for gene expression. Even a small change in microRNA activity can significantly affect how much protein is produced. This mechanism is essential for normal development and cell function. For example, microRNA helps control cell growth, differentiation, and programs cell death. When this regulation fails, it can lead to diseases. Abnormal microRNA activity has been linked to cancer, neurological disorders, and cardiovascular diseases. The discovery of microRNA changed our understanding of genetics. It showed that genes are not simply turned on or off, but are carefully adjusted. This added a new layer of complexity to molecular biology. In addition, microRNA has become an important tool in medical research. Scientists are exploring ways to use microRNA in diagnosis and therapy. For example, specific microRNA patterns can be used as biomarkers for diseases. There is also potential to design treatments that target microRNA pathways. I find this discovery fascinating because it reveals how precise and dynamic biological systems are. It shows that even very small molecules can have a huge impact on life. In the future, research on microRNA may lead to new treatments for many diseases. This award reminds us that understanding gene regulation is key to understanding life itself. Thank you.